Multi-burst envelopes is a 12 HP wide EURAC module. It's available in black or a silver front panel. There's very low power needs at 28 milliamps on a positive rail and 12 milliamps on a negative rail. It's only 26 millimeters deep, so it fits shallow skiff style cases. It generates a burst of repeating envelopes, and this can be from 1 to 40 bursts. Eight different envelope shapes can be selected by a rotary switch. And they can also be controlled by an external CV. The burst sequence of envelopes can be triggered from an external gate or trigger signal, or from the front panel trigger button. The rate of repeat of the bursts is controlled by the LFO rate control, and this can also be controlled by an external CV. The LFO can be turned off, and then either the clock button or an external gate signal can be used to step through the envelopes within each predetermined number of bursts. Long or short envelope times can be selected with the pulse width control. Or this can also be CV controlled with the pulse width CV input. The individual envelope level can increase, decrease, or remain the same during the duration of the burst sequence depending on the setting of the slope control. The module has a re-trigger mode which will allow the sequence of bursts to be restarted immediately, or a one-shot mode where the sequence will be completed before a new sequence is begun. There's a gate output that goes high during each envelope, and on the left hand side there's an LED that remains lit whilst the burst sequence is running, and on the right hand side an LED that follows the level of each individual envelope in the burst sequence. Eight different envelope shapes are available, and they're selectable by the rotary switch. If an external CV is patched into the envelope CV input, then the front panel switch is bypassed, and a CV between 0 and 5 volts will select the envelope shape. So I've got a signal coming from a sequencer, and at the moment the sequencer is just triggering the envelope, but I've got this bottom row here, the CV output, connected to the CV control of the envelope shape. So as I change the value of this pot, it will select different envelope shapes. And if I run the sequence, I've got all these CV values set to different envelope shapes across 8 steps. The envelope type can be changed whilst the burst sequence is running. So in this example I've got an LFO triggering the multi-burst envelopes module, and its gate output, which sends a gate for every envelope going to the dual RVG, and the random voltage from the dual RVG going to the envelope shape CV input, so that each time a new envelope generates a pulse, the dual RVG then changes the envelope type. In this patch I've actually got the multi-burst envelopes controlling both the frequency of the filter and the pitch of the VCO. Envelope 8 is a simple on-off envelope, however its level is controlled by the slope control. So this envelope is more useful than it would first appear to be. The front panel burst control is used to select the number of burst sequence, going from 1 up to the maximum of 40. The number of bursts can't be changed whilst the burst sequence is running, and any changes will be ignored and only applied to the next burst sequence. And also the pot is non-linear, so its halfway position will actually be 10 bursts as opposed to 20. The reason being is it makes it easier to dial in a smaller number of bursts. An external CV can also be used to control the amount of bursts, and in which case the burst pot then becomes an attenuator. So if I use the RVG to trigger the multi-burst envelopes and take the voltage 2, which is a random voltage, and put it into the burst CV input. So at the moment you're only getting one burst. As I increase the attenuator, it'll start to vary as it allows progressively more influence from the RVG. The pulse width control determines how fast or slow each individual envelope will be. This can also be controlled by CV using the pulse width to CV input, and in which case the pulse width control then becomes an attenuator for the incoming CV. I've got the RVG triggering the multi-burst envelopes at the moment, and if I take random voltage 2 and connect that to the pulse width CV and set the attenuator to its lowest point so there'll be no variation, and you just get the shortest envelope, and I'll raise it to its maximum. All of the envelopes are of the AD or attack decay type, but by using the gate output you can also trigger external ADSRs or more complex envelope generators, or even dual RVG like I was doing earlier on. With envelopes 2, 4 and 7, the attack rate is fixed at a very fast speed, and the pulse width only controls the speed of the decay portion of the envelope. With envelopes 3 and 5, decay rate is fixed at a very fast speed, and the pulse width only controls the speed of the attack portion of the envelope. With envelopes 1 and 6, the attack rate and decay rate are varied simultaneously with the pulse width control. With Finally, with envelope 8, this just controls pulse width uniformly, so you're controlling the duration of the peak of the envelope signal. The pulse width can be varied whilst the burst sequence is running. So we could start with a slow envelope speed and then have it decrease during each sequence of bursts. Or even something like a sequencer could be used to individually control the speed of each individual envelope in a burst sequence. The pulse width setting does not have any influence over the burst rate timing, so it's possible, although not particularly useful, to set the envelope to be longer than the individual burst rate timing. We implemented it this way so that the overall timing of envelope repeats can be accurately controlled by the onboard LFO or by an external clock. The LFO rate pot controls the speed of the repeats and can be changed during a sequence of bursts. When an external CV is patched in to the LFO CV input, LFO rate control then becomes an attenuator. So here I've got an envelope controlling the speed of the repeats, and the envelope is also being triggered by the LFO, as is the multi-burst envelopes. The LED on the right hand side shows the LFO rate, or rather the speed of the clock pulses, as it responds to both the internal clock and the external clock. The internal LFO stops completely when the LFO rate pot is turned fully counterclockwise, and if a burst sequence is running at the time, then the LED on the left hand side will remain lit to show that a sequence is still active and is waiting for a clock pulse, either from an external clock patched into the clock input or by press on the manual clock button. As a repeat or LFO rate increases, the pause time between envelopes decreases, so it may be necessary to increase the speed of the envelopes by turning the pulse width pot anti-clockwise to avoid having envelopes that are slower than the repeat rate, which will cause envelopes to overlap. The slope control determines the level of the envelopes during the burst sequence. They can increase in level, reduce in level, or remain the same. If slope is set fully counterclockwise, then the first envelope will be at a very low level and the last burst will be at a maximum level. But if slope is set fully clockwise, then the first envelope will be at maximum level and the last burst will be at a very low level. And then if slope is set at centre, then all envelopes from the first to the last will be of an equal level. The relationship can be set between the maximum and minimum envelope levels for the slope pot. For example, if the pot is set to 9 o'clock, then the first envelope will be at 50% maximum level, and each subsequent envelope will be louder until the last envelope, which will be at maximum level. The slope cannot be changed whilst the burst sequence is running. Any changes will be ignored and only be applied to the next burst sequence. There are two separate modes of operation. In one-shot mode, once a burst sequence is started, the trig input and the trig button are ignored and the burst sequence will run for the number of bursts set by the burst control. then only when it's finished will it start a new sequence. In re-trigger mode, once the burst sequence is running, the trigger section is still active, so pressing a trig button or by sending another short gate or trigger will immediately stop the sequence that's running, reset the number of bursts and slope to new values if these controls or knobs have been changed, and then will immediately re-trigger a new burst sequence. In addition to the internal LFO, the envelopes within a burst sequence can be triggered by an external clock, or the front panel clock button, or a combination of all three. So with the LFO control all the way down, the burst sequence will pause and wait for a clock pulse to generate the next envelope within the sequence. And it will produce one envelope for each pulse received. So if we set the amount of bursts to 10, and start the envelope. Now it's waiting for a clock signal or a press of the clock button. Now it will take me 10 presses to go through the whole burst sequence. The LED on the right hand side illuminates each time a clock pulse is received, either internally or externally, and it remains lit for the duration of the individual envelope, which is set by the pulse width control. Whilst it's doing this, it's still possible to run the LFO so that extra clock pulses are added at the same time, making it possible to create more complex polyrhythms. By using a repeating external trigger signal, you can make the module loop. And in this case, I'm using a VCO at audio rate, and I've got a cable coming from a square output. It's going to the muting mixer so I can turn the signal on and off that's going through to the module, which is connected to trigger input. So if I turn it into one-shot mode, what will happen is every time it receives a trigger signal, it will play through the sequence of bursts, depending on how many bursts I've got, and also still answering to the LFO rate and pulse width. Then when it's completed the end of the last envelope in the sequence, so that will be affected by pulse width, once it comes to the end of that last envelope, then it will re-trigger itself once it receives another trigger signal. And the idea of using the VCO for that is it means that those incoming pulses are incredibly fast. So as soon as the module has finished its last envelope, it will then listen out for another trigger signal, which will be almost immediate, and then restart the sequence. So as soon as it's finishing that last envelope, it's restarting the sequence again. But that's also affected by the pulse width because it's waiting for the end of the last envelope. So if I make the envelope longer, it slightly changes the duration of the overall sequence, and then making it shorter. And then LFO rate still comes into play. And slope as well, which of course won't change the actual slope being employed until the sequence is finished. And also amount of bursts won't change until the end of the currently running sequence. And by using the muting mixer, if I set this up with a long sequence of bursts, I can just turn this off and it will finish whatever the current sequence is. Even though I've turned off the signal going to the trigger input. And of course I can do the same thing with an LFO, but if I set the LFO to a slow enough speed so that it's significantly greater than the duration of the envelope sequence, then there'll be a pause whilst it waits for another trigger signal. slowly LFO down even more. Because the module has a gate output, it can trigger other modules such as additional envelope generators or complex envelope generators, or even something like the dual RVG as I did earlier on. At the moment I've got the gate output triggering the HADSR, and the output of that is doing the same job that the multi-burst envelopes was doing before, which was modulating the pitch of the VCO and the frequency of the filter. I'm using the 8th envelope shape, which is just a pulse shape envelope, and at the moment the envelope settings in the HADSR is instant attack, no decay or release, and full sustain. But as I start to change the pulse width, you'll hear that the pulse width on the multi-burst envelopes will actually affect the duration of the envelope. Because I'm sending it a gate signal, then if I send a shorter pulse width, it's like sending a shorter gate signal. But then I've also got the functionality of the DHADSR. So if I back off a sustain to 50% and increase the decay, and then give it some release as well, and then change the pulse width, I'm still not using the output from the multi-burst envelope, so I can use that to control VCA. The offset on the VCA is constantly allowing sound through, so I'll turn that off and then turn up the CV, so now it's purely being controlled by the multi-burst sending it these pulse waves. But then that means I can use a slope control. Meaning I can control the volume of the repeats, I can control their amplification. However, when you're using the multi-burst envelopes to control an external envelope generator, then the envelopes within the module aren't being used, because we're using them to trigger the external module and the external envelope generator.
Thank you.